We are going to look at some word problems dealing with discrete and continuous domain and range. So the first one is discrete. So in our vocabulary, discrete means a function with distinct and separate values when graph values are not connected and it's only whole numbers. We are going to make a list for domain and range. So we are going to put only whole numbers, make a list for domain and range. And we do the list with the little braces, remember? You list out your numbers. X is domain, right? Domain is X. Range is Y. You make a list. And you put commas in between the numbers. Okay, continuous domain and range. Continuous means a function with any value between a certain interval, graphed as a single unbroken curve or line. So that's from the vocabulary. So this could be any number between two numbers. So we're going to call that an interval, where you'd say like y is between these two numbers. We are going to write an inequality for domain and range. And the inequality for domain is going to be 0, or a number is less than x is less than another number. Or it could have that or equal to. And then range is the same thing, just with y. In the blanks go the numbers. If you have arrows, you use infinities. Negative infinity or positive infinity. Okay, so go ahead and open up the inside or your little booklet. I'll wait just 5 more seconds. Okay, so we have 2 word problems. So we're going to have to figure out what it's saying. Is it discrete or continuous in the domain and range? And then do a little bit of function notation. Number 1, a set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair of weight plates weighs 20 pounds. If X pair of weight of plates are added to the barbell, the total weight of the barbell and plates in pounds can be represented by the function f of x equals 20x plus 4. We need to determine, is this discrete or continuous? So discrete means only whole numbers. So we need to talk about what our variable is. What is x represented? X pairs of plates. So x would be pairs of plates. So it's like, y'all know what the weights look like. They have this little thing. So each pair is 20. So each little plate is 10. But you got to put pairs on in order for it to be balanced, right? Can I have part of a pair of plates? No, it's only whole numbers. So this is discrete because we can only do whole pairs of weight plates. We can't do parts. Like, you can't cut up the weight plate. Like, I don't have anything that could cut up a weight plate. You have to use some kind of like torch or something to do part of a plate. So we're only doing whole plates. So you can only put on, it says they have 6 pairs. So you get to choose how many you put on. You could just put none on and you're just lifting 4 pounds, right? So for domain, it's going to be how many pairs of plates we can have. That's our X value. So we could do 0 pairs. So we're making a list, remember? X is your pairs of plates. We could do 0. We could put none on there and just lift up the barbell. We could do 1 pair, and that's the 20 more pounds on top. And it says we have up to 6 pairs. So that means I can do all the numbers, all whole numbers, between 0 and 6. Okay, then we got to find out the range. So range is y. So let's figure out what the y values represent, or f of x. F of x and y are the same thing, right? Don't forget, f of x and y are the same thing. That might be on your test. So I'm going to put f of x out here. F of x, which is y, is our, what is it? Range. So we've got to know, what are we actually calculating when we use this 20x plus 4? We're calculating the total weight. That's the barbell with the weights on them. I like my depiction of the weights. It's beautiful, right? It's all of it together. It's your pairs and it's your barbell all together. So then we need to know what the range is. So we can use our calculator. Okay, one way to do it is to look at 20 times x plus 4. We can do it in the home screen, or we can do it using y equals. I'm going to do it with y equals because it'll give me all the values that I need. So go to y equals, and let's put in 20x plus 4. So we want to know what the y values are when the x values are 0, 1, 2, 3, 4, 5, and 6. So we're matching them up. So go to the table, second graph, which is your table. And let's find the match. So 0 pairs, because remember x is your pairs, is 4 pounds. Because you don't have any of the plates. So this matches with, I'm going to put them right underneath each other. 0 is with 4. And then 1 would be putting a pair, which is a 20 plus 4 more, which is 24. And then we got 2 more, or 1 more pair, which is another 20 pounds on top of that. So 44. Another, go to 3, 64. 4, 84. 5, 104. And 6, 124. And you can only go up to 6 because in the word problem it says a set of weights include a 4-pound barbell and 6 pairs of weight plates. So you can only put a maximum amount of 6. This is your max. Our minimum would be 0 pairs. It'd be putting none of them on. Okay, so now we need to do f of 4. So if you put 4 plates on, we need to know how much it would be. So we can use our table again. 4 would be 84. Okay, let's go to number 2. The daily cost of hiring a plumber Y to work X hours on a repair project can be modeled using a linear function. The plumber charges a fixed cost of $80 plus an additional cost of $45 per hour. The plumber works a maximum of 8 hours per day. So we got to know if this is discrete or continuous. Let's identify our variables. X. We don't have an equation like the last one, but we can create the equation. Plumber charges $80 plus $45 per hour. So the variable is $45 per hour. So the variable is hours. Hours worked. And then Y would be the total charge. The plumber charges, right? So total charge. So we've got to know if it's discrete or continuous. Remember, continuous is on an interval. Discrete is only whole numbers. So for continuous, it could be parts of a whole. For the hours, can you charge for a half hour? For a quarter of an hour? For like 0.1 of an hour? Just like you can get paid at your job based on how many hours you work, including if you just work half an hour. So this would be continuous. Why? Paid for half an hour. Basically, we can have parts. They're not all whole numbers. Your customer would be really mad if you only worked half an hour, but you pay. If you only worked half an hour, but you charged them for a whole hour. So what is the domain? So domain is our X, hours worked. So it says a maximum of 8 hours. So what's the minimum? If the maximum is 8 hours, what would the minimum they would work? I would say 0, because they could show up, right? So 0. But remember, we're making an inequality because it's on an interval. So it's 0 and then a max of 8. So we'd say less than x less than 8. But they can work 8 total hours. They could work 0 hours, just show up for the time. So 0 to 8 is 0 is our minimum, 8 is our maximum, so we write it on an inequality. Okay, so now we've got to come up with a range. We can write it the same way, but with y. So we've got to find out what these numbers are. You can use the calculator again. So let's see. For 0 hours, how much are they going to be able to charge? It's $45 per hour. But what's the fixed cost? $80. So for 0 hours, it's $80. These match up. And then for 8, let's figure out how much it'll be for 8 hours. I'm going to go to the home screen. You can hit second quit. They're right next door to each other on your calculator to get to the home screen. So it's $45 per hour. So 45 times 8 plus the $80, $440. Okay, and then our last thing is f of 3. So this would mean 3 hours, right? Because x is 3. So it'd be 45 times 3 plus the $80, $215. Okay, go ahead and glue this in. Let's look at the worksheet from the last lesson. I have the first one done for you. Don't forget that domain is x and only x, and range is y and only y. So for the first one, x is less than or equal to 5 is actually what it's going to be. Remember, we simplify it. It's from negative infinity to 5, or x is less than or equal to 5. And then your range is from negative infinity to 2, because your down part is an arrow and it goes up to 2. So we simplify that one too to be y is less than or equal to 2. Okay, the next one, don't forget x is domain, y is range. Domain is left to right. So the left side, we're going to put a dotted line. The right side, we're going to put a dotted line. So we look at the numbers on the x-axis. It's -5 to -2. So that's going to be our interval. From -5, where x is in the middle, to -2. So don't forget, if it's on the left side of the origin, it's negatives. And then the open circles mean we're just going to have less than. If you want to shade or highlight, you can. And then y is the range. We're going to do low to high, or down to up. So the furthest down it goes is down here. So put your dotted line here. And then up to positive 4. So if I were to shade this, I'd shade that, I'd shade that, then I would shade this. So see how the only part that is not shaded is the part where the graph is. So if you were using a highlighter, it would look like this also. And it makes a rectangle. It'll always make either a rectangle, a square, or have some like areas that are off the grid. So let's look at what y is going to be. So remember, range is y. So we're going to go down to negative 4 and up to positive 4. And they're both open circles, so it's just less than. Okay, I want you to do one more for a total of 4 problems now. And then you'll turn it in and then get on the quizzes that'll be on Canvas. And y'all can help each other out.